In this class, we're going to take a look at how you multiply and divide surds, or you may call them radicals. So surd and radical is the same thing. So the key to this technique is to know that if you take two surds, so if you take root A and you're going to multiply that to root B, then all you need to do is to form that into one surd where you multiply A and B. So one surd, underneath that surd you've got A times B. That's really the premise for this technique. But the important thing to know as well is that that also goes backwards. So if you started with, say, the root of A times B, then you can also split that into root A times root B. So that's really the basis for how we're going to go about multiplying these guys together. And then we'll take a look at a division example. It tends to be that multiplication of surds is more popular, a more important technique than division. But it all kind of rests upon this idea here, and then maybe one or two other considerations as well. So taking the first example, this is fairly straightforward. It just falls directly into this kind of format here. So we can just simplify that by making that the square root of, well, we can write in 3 times 5, although eventually you'll probably just drop that line of working. 3 times 5 is 15, so that just becomes root 15. So we've just multiplied together those two surds to get this new root 15. Okay, so that's all we have to do for that one. For this one, root 4 times root 4, slightly different format in the sense that these are both the same number. So let's just think about what kind of quirks that might throw up. Taking the same approach as we did up here, we're going to get root 4 times 4. So again, you'll probably end up dropping that line of working. Root 4 times 4 is root 16. Now this one will actually go further because the square root of 16 you can actually process to get a whole number. So that just comes out to be 4, okay? But notice that 4 is a number that we started with. And the reason why it's come out to be that number is because root 4 times root 4, you can also think of that as being root 4 squared, right? Because something times itself just means that thing squared. So root 4 times root 4 is root 4 squared. But a square root and a squared are inverses of each other. They cancel each other out. So the square root of 4 squared is just 4. So if you ever see a scenario where, for example, this is A and that's A, then the answer would just be A. So let's maybe just add that to our list over here. So if you've got root A times the same root, root A, the answer to that would always just be A. In other words, the roots disappear, they cancel. So root 4 times root 4 is just 4, either for this reason or for that reason. So you can think of that in either way, but that's kind of a special case, that one. Generally, they're going to be different numbers. Okay, so progressing this forward, looking at the third example, we've got the same root, which is fine, but we've also got numbers in front, so we need to know what to do in this scenario. Well, in this scenario, you basically multiply the numbers together, the whole number, so 2 times 3 to give you 6, and then root 5 times root 5, which we've just established is going to be just 5. So we just figured out that root 5 times root 5 is going to be root 5 squared or root 25. Either way to think about it, you get 5. So it's going to end up being 6 times 5. Okay, 6 multiplied by 5, which is 30. So that's how that one would come out. So a slight change there, having the numbers in front. So just remember, you need to multiply the numbers together as well as multiplying the surds together. So the final example, which is probably the most complicated scenario, is when you've got these kind of bigger numbers, and you could just multiply those together, okay? You could multiply them in the same way we did 3 times 5 to give 15, but these are big numbers, so I don't really fancy multiplying those together. Another way you can go about this is to simplify the surds down to a lower form. Now, we're not covering that in this class. How you simplify surds, you may already know. If not, you can check that out in another class. But this number, root 27, simplifies down just basically, I suppose, really using this technique. It is effectively just using the technique we've got here. So simplifying down, 27 is 9 times 3. So we're thinking of the 27 as being 9 times 3, and then just splitting that into root 9, root 3. So we're going to make this guy root 9 and root 3. And we're multiplying that to root 32, which we're going to break down as well. So we're going to make this one root 4, root 8. You can choose any numbers that multiply to give you this number. So that could have been 16 and 2 or 4 and 8. I've gone for 4 and 8. but there's always like an optimum kind of number to go for. So just taking this forward, in fact, let me change that. Let me go for 16 and 2. I think that's going to form a better number pair. You get the same answer eventually either way, but I think this will be more efficient. So 16 and 2. So root 9 is 3, so we get 3 root 3. Square root of 16 is 4, so we get 4 root 2. Multiplying those together, which is now in the format that we had up here, 3 times 4 gives you 12. Root 2 times root 3 gives you root 6. So the final answer there would be 12 root 6. So I went for the 16 and the 2 here because 8 and 4 is fine, but neither of those is a prime number, and you always want it to break down to some square number, ideally in some prime number. So making it 16 and 2, that's a square number, that's a prime number, so that's a better combination. So that would be the final answer there. So let's maybe look at a case where we're going to divide. So division, a little bit less important, I would say, a little bit less popular of a technique. So let's say we had root 32 over root 8. So one way you can just do this, which is really, really simple, is just to divide the numbers and put that under one square root. So basically, or to put in an intermediate step, it would basically be one big square root and then 32 over 8, like that. 32 over 8 though is just 4, so that just becomes root 4. Square root of 4 is just 2. Now that happened quite nicely because these numbers divide quite nicely, but notice that these two roots with a fraction turn into one root, so that goes both ways. So you can turn a fraction into two roots or two roots into a single root if they're fractions like that. Another way you could do it is to simplify the numbers. So we saw over here that root 32 is 4 root 2. So just taking a different approach, we could make that top line 4 root 2 by simplification. We could make the bottom line root 4 root 2. Yeah, root 4 root 2, just by simplifying that one, root 4 root 2. And then that gives you 4 root 2 on the top. Square root of 4 is 2, so that becomes 2 root 2. In that scenario, the roots would cancel because they're top and bottom of a fraction. That's not exclusive to roots, that happens for any number type, so they're effectively going to cancel. You end up with 4 divided by 2, which gives you 2. So the answers have come out there to be the same as they should, regardless of which of the techniques we used. So in this technique, we just simplified the numbers down to their lowest form and then tidied it up from there. In this way, we turned the two roots over in the fraction into one root and kept the fraction underneath the root. So slightly different technique. One of the other techniques you'll need to learn in this topic, but we're not going to cover it in this class, is how to rationalize a fraction. So rationalizing a fraction is when you've got, basically you've got a root on the bottom of a fraction. So 1 over, say, root 5. We don't like to have roots like that on the bottom of a fraction, so there's a technique for turning that into a fraction, which actually in this case it ends up being root 5 over 5, where we flip it in a certain way, and it's called rationalizing the fraction. So that's quite an important technique, but we're not going to discuss that in this class. You'll need to check out another class to get information on how that one works. So that's basically how you multiply and divide surds. Not easy, not terribly difficult, it requires a little bit of practice, so just try to see all these different situations so that you're able to adjust to different scenarios and answer a wider range of questions. So make sure that that makes sense and then try some of the practice questions.